I'm going to assume here that we have had this class here, even if people don't want to attend. Here's the thing. I would kindly like to request if one of you could please confirm if you can see my screen and if you can hear me just fine, please.
Yes, sir, you're visible and audible.
Okay, thank you very much. So we've had a what I feel is a very productive conversation centered around how we go about manipulating data, analyzing data using Python pandas. Granted, most of the things we focused on are things that we feel are going to be relevant for you to be able to follow through with examples to be used in class, for instance. And then I think something worth mentioning here is the fact that very soon, once we start going through the crisp DM model phases, a lot of things we've discussed so far are going to be pretty intuitive. So you see a lot more things coming up. But I just wanted to find out before we start here if there are any specific questions you have about what we've covered so far. Wonderful. And that's the beauty when you're working with fourth years, right? They're able to grasp things rather quickly. But here's me telling you that if you go online, you'll be able to find a whole slew of documentation, right? Regarding Python pandas, there's actually a dedicated website, so pandas.pydata. And on that website you have documentation available, but also as you're busy working with Python pandas, what you begin to notice is that you can actually run these built-in commands that were introduced to you. I'm not really sure which course which course introduced you people to Python really. But what you begin to notice is you can run things like the help command, for instance. So if I do an import pandas as PD, for instance, I can do something like, help, PD, and then, I'll have details or detailed documentation available to me as I'm, working with Python pandas. And, through this, locally available documentation, after you install Python pandas, I can, search through whatever it is I may be working towards. And something else I found interesting really is to make use of other additional built-in functions. Like if you remember the dir, is it? So if you do a help on dir, I don't know if you remember this, but this documentation allows you to gain a sense of what a particular function is all about. So there's that. Anyways, with that being said, today we're on a transition here, right? We're going to transition and look at another package that you see me using often, and that package is called Matplotlib. So Matplotlib is ideally a graphing or a visualization centric package or library. So it will enable you to visualize data. And I think you've probably seen me do this, right? Like for instance, when we were using Python pandas to group things, I think I showcased an instance where I chained commands in order to generate some plot or something, because implicitly I was using Matplotlib here, if that makes sense. Anyhow, so the motivation for doing this is simple, right? What we're going to do immediately after this this lecture is we start going through what's called a typical data mining approach, and so we'll look at how approaches like schema and KDD, so knowledge discovery in databases process, things like the CRISP-DM or CRISP-ML models, how these things actually would segment your typical data mining, project that you'd be working towards here. Now, I say this because it turns out that if you look at the broad spectrum of activities that you perform as you're, working on a data mining project, you typically start off with, and if I can latch on to the CRISP DM model here, you have what's called business, understanding, right? I'm going to discuss this in depth here. But after business understanding, you have what's called, and I'll call this something like data preparation or something, right? Or data understanding or something. And then you'd have this, just say data understanding or something. You have, data preparation, you have, kind of modeling, you have evaluation, and then you'd have something like deployment, right? I may have butchered the order of the phases, I may have renamed them, but the idea still remains the same. Now, what's particularly interesting about these broad phases associated with your typical data mining pipeline is that there's a series of activities that you perform. Okay, I'll give you an example of I would say data understanding, for instance. It turns out that some of the things that you do as part of data understanding we entail or we involve you trying to figure out what sort of data sources you can use, right, to implement your solution. So you identify the data sources. So it's like, well, we want to build this application that's going to enable us to predict students that are at risk of failing in CSC 4792. Okay, the question is, well, if we are to build a data mining centric solution, we need data, right? So the question would be, where exactly is this data going to come from? Okay, and so you'd say, oh, potential solution for our data would be maybe SIS, for instance, right? The student information system. Okay, now when you identify, and there could be like a whole host of data sources, right? Like, for instance, maybe the course instructor, yours truly here, will say, well, I think what we're going to do as well is we're going to see if we can leverage, or we can try and use attendance in virtual classes, because this course has 3 lecture sessions in a week, and out of those 3 lecture sessions, 2 of them are held virtually. If they're held virtually, then maybe we can take advantage of the data that the course instructor uses to keep track of attendance and use that as a marker for determining engagement, right? So it's say, well, we're going to collect data about all the sessions that we've had, right? Like this current session here. I'm going to keep track of who is attending the session, perhaps for how long they're attending the session, right? So like in this particular case, we'd say, well, for each student enrolled in the course and for all lecture sessions, we are measuring their engagement by utilizing attendance as reflected in online lecture sessions. Now the thing is, when you collect this data, right, before you can actually invest your time and resources into implementing the models, for instance, and ultimately the solution, or implementing the end-to-end solution, what you have got to do is you've got to perform some sort of sanity check, right? And that sanity check will sometimes involve, or primarily involve, a process that is called exploratory data analysis, or EDA. As part of EDA, most of the things that you do involve graphing, right? So generate a whole host of plots. It's like, well, we're going to look at, we're going to see if we can cluster these students, right? And we're going to cluster these students based on their performance in the first test relative to their attendance, the attendance metric or something. We're going to look at different, categorical attributes associated with information we've harvested from SIS. In addition, there are indeed certain other phases like evaluation, where what you're doing here is you're trying to demonstrate the efficacy, for the most part, in some instances, the efficiency associated with whatever model you would have implemented as part of modeling. Now, usually, this efficacy manifests itself as visualizations, right? I mean, you can write down these things. You can type in, what do you call this? You can type in evaluation results, right? To say, well, we see here that the performance was 90% or something, right? But it turns out that that is generally not very intuitive. It's not very useful, right? What is useful, usually easier for people to understand, is something akin to what you're going to see in this paper here: graphs. Okay, visualizations, graphs. So it turns out that the point I'm trying to put across here is that it's imperative, it's important that we understand exactly how we go about visualizing data. It's one of the reasons why we are discussing Matplotlib. The other reason is it's part of the syllabus. That's it, right? But anyway, and if I can kind of latch on to the data set, I don't know how many of you have played around with this data set. I attempted to use visualizations as they relate to the two data sets that we used. I guess 3, including Lusaka Times data set here. But it turns out that, as the white man says, apparently a picture is worth 1,000 numbers. I don't know if it's 1,000 numbers here or words, but 1,000 numbers, I guess. Play on words here, ladies and gentlemen, right? If we're to identify interesting patterns as they relate to the student performance data set, for instance, we see here, right, from this graph, you have access to the data, quite right? Which is here, I guess. You have access to this data, is it? Well, put in Python here, not Python, but Python, right? And then when I put in Python, I'm going to use my Python pandas. Let's just hit it down here. I'm going to use my Python pandas, import it, right? And then I'll say student database or something, pd.read CSV, underbar CSV, underbar CSV, right? Sep, it's a pipe symbol. I read this information like that, right? I mean, I can do all sorts of fancy things we discussed here, is it? Like I say, well, I can kind of inspect it like that, right? Look at the columns or something. In fact, I can even generate descriptive statistics associated with the data itself. I can do, by the way, most of these functions I run here, they're overloaded, so you can feed them with different parameters. Your task is to figure these things out as you're playing around with the data, right? So you want to make sure that you play around with built-in functions. Like if you said .describe here, I can say, I can say help, right? And it's going to tell me what this does. Describe with all of these overloaded messages, parameters, right? These keyworded parameters. You notice by default all of these are now, but you can modify these things, right? But you see, the thing here is that this is not enough. It's not enough to give me an idea of the data itself. What sort of information associated, useful information associated with this data? I must graph. Now I have an example here, right? I generated something from the data, an interesting pattern here where we see that there is a difference between students that are minoring in STEM-centric programs, like mathematics, for instance, right? When compared with those like minoring in social science programs. And we can see this, right? If you look at the vertical dotted blue line here, this is showcasing the average or the mean score associated with the final results for those that are minoring in STEM-centric programs, whereas social science is here, right? It's somewhere here. We see that there's a difference here. We wouldn't be able to immediately tell this difference if we're just looking at the raw numbers, right? So plotting is important for that particular reason. Okay, but also what's important is that graphs allow you to effectively communicate your findings, right? It's like on average, which group performed better? Well, we see that the STEM-centric group performed better than the others, right? We can see here from the distribution, the histogram that we have here, right? Anyhow, So Matplotlib really happens to be one of those most widely used visualization packages, if you will. It's not the only one. There are a slew of them out there, but the average person will probably use Matplotlib here. And it turns out that it forms the basis for most other libraries that people have come up with. Like, for instance, Seaborn, right? Seaborn is built as a layer on top of Matplotlib, you know. And if you want, I don't know here, but what you can do is you can even go outside of Python and say, well, what I'm going to do is I'm going to use R for my graphing purposes. Nobody cares here, but remember what we've mentioned from the outset is that overall, when you're implementing or you're working on a data mining problem, you are creating a pipeline that is ideally supposed to be created in such a way that um, it makes use of the similar technology stack, right? You don't want people to context switch. Or for you to look at the visualizations, open up or run this command in R, for instance. For the actual evaluation or model implementation, we're using Python. It's possible, but it's not an elegant solution. Okay, if that makes sense here. Okay, so really what Matplotlib does, it provides you with a low-level interface for creating a broad spectrum of plots. And you see this, right? What I'm going to do here is I'll walk you through the process in which you assemble a plot. You know, you are really creating a plot in a rather in a vastly different manner when you compare it to how you create plots in, let's say, Excel Go Sheets, right? You know, in this particular case, you build it piece by piece. So we'll go through those things here. And also, because Matplotlib, again, when you come here and you say, I think I have Matplotlib here, and I do a DIR, what you notice is that Matplotlib is like this large library, right? Massive library, right? It's an object-oriented plotting library. And because it's massive, we're not really going to look at all the aspects of Matplotlib. There's quite a bit that you can do in Matplotlib. But however, our focus is going to be on the PyPlot module, right? So we're going to be plotting using this module. So in other words, you will see me do this. Matplotlib.pyplot. Okay? This is what we are using here primarily. And this is sufficient really to enable you to generate the average type of graph that you would use as part of EDA, as part of evaluation, and all those things. It's more than enough actually. If I do a DIR for what you call this PyPlot here, what you begin to notice is there's a broad spectrum of, I mean, you may not really see some of these things here, types of plots here, like a bar, for instance, right? Bar H for a horizontal bar plot. This is the vertical bar plot, your default one. You have box plots, right? You have line plots. You have a whole slew of things that you can plot just by using the PyPlot module, okay? So that's going to be our focus. Now, in terms of getting started, again, if you're using, I want to avoid here doing the live demo from Google Colab. Sometimes bad things happen here, but I have dedicated Colab notebooks that I've made available on the Moodle. So you see me context switching to my terminal because I'm running these things locally. And it's much faster actually than me firing up Jupyter Lab and context switching and stuff. But the idea is the same. It doesn't matter whether I'm running them from here or from Jupyter Lab. It's the same, right? So your Google Colab and Anaconda, if you're using Anaconda, will come pre-installed with Matplotlib, just like they're pre-installed with Pandas, so you don't have to worry about these things. However, if you were to run this locally, like I'm running it using the Python interpreter, one of the things you would have to do here, I'm just going to close this, is you would have to run the pip command, is it? So you do your pip install Matplotlib, right? And then the magic is going to happen. So this thing is going to install Matplotlib on your computer or something like that. Now you notice here I'm getting a requirement already satisfied kind of verbose output because I already have Matplotlib installed. Okay. Another way in which you can install Matplotlib, if you're using a Debian-based operating system like Debian itself or Ubuntu, is you can use apt-get. I've done this in the past where you actually install Matplotlib, and this kind of shows you just how useful Matplotlib is, right? If they've decided that they're going to have a dedicated package in the repository, Ubuntu repository, it goes to show just how important this thing is. So you can run, sudo apt-get install Python 3 Matplotlib, so that you have like this global installation of Matplotlib, right, on your computer itself. Anyways, and then in terms of how you use this, similar to Python pandas, for you to use Matplotlib, remember we said that we're going to be using pyplot. What you are going to have to do is in your Jupyter Lab or something, or Google Colab, before you can use Matplotlib, you must import it, right? So you're going to import, after installing it, Matplotlib. Remember I said we're using the pyplot module, right? So you're going to be matplotlib.pyplot. And by convention, you don't have to do this if you don't want to. By convention, you use an alias called POT. Okay? And then what you then start doing is you start constructing your plots, your visualizations using the alias POT, if that makes sense. If you want, right? If you're a rebel like that, what you can do is you can do the usual stuff. Is from matplotlib import pyplot as pp. Now you're a rebel here. So it's one and the same thing. You see, I can do a POT dot as it's a plot here, maybe 1 2 3 4 or something like that, and then do a POT dot show. What this is going to do is it's going to show me and it's a lousy thing here because it was supposed to be a list here. I've worked as a list, but it doesn't matter, right? We can fix this. Let's see. We can fix this slightly and do this. Obviously work here. You can draw a plot, right? Like this. I'm using POT here to plot. If you've noticed, I have 1 2 3 and stuff. Well, it turns out that I'm going to cancel this. It turns out that I think I have to explicitly close this as we go on here or something. It turns out that if I decide to use the import, like from matplotlib import pyplot as pp, then what I would have to do here is not what I would have to do. This works as well, right? So I can come here instead of POT here. I'm going to say pp, and then I'll have pp.show, and it will work as well. I'm just putting it out there that the way that you import these things here, there's no standard a single way of importing things in Python, is it? You can do a from library or package import the actual specific module or something, or you can do import library dot the module that you're looking for or something like that. Or if you want, you can do the usual, right? It's like import. This is a big one here. Import from matplotlib, just say import everything. Actually, it's import everything. This is not efficient, right? But you can say import everything, and then you'd start the things like pyplot. I don't know why pyplot is not coming up here from matplotlib. I don't know if then I would have to say matplotlib. I don't know why this is not working. This is supposed to work, right? Import everything. It is supposed to work, but why? Pyplot. Oh well. I don't know why it's not working here, but I wanted to showcase. I want to showcase that it's probably something off here. I don't know what it is. I'll have to look it up later on. I want to showcase that you can actually import everything from this library itself, right? I don't know if this would work here. Pyplot or something. Don't know why it's not working. Rather weird here. But anyways, different ways to import these things, right? However, I think what's also important here is to mention that we, going forward from here on, we're going to be using Matplotlib in conjunction with Python Pandas because we're interested in visualizing data that is imported using Python Pandas. And so what we will be doing, what you notice us doing, is we're going to be doing things like import pandas as PD, and then you say import matplotlib as matplotlib.pyplot, right, as plt, like this. And then we'd read our data using Python Pandas, okay, probably in a variable or something. We apply a lot of sophisticated things, operations on the data itself, and then we visualize. Like for instance, you'd say one of the things we want to do, and I don't know if I've already swallowed this data here. One of the things we want to do is we want to visualize scores, right? So import Python Pandas, we import matplotlib.pyplot, and then we'd say, well, I'm going to read our student data set. And the way we are reading the student data set, we are using the read CSV because it's a CSV file. It's pipe separated, like so. Don't know why this thing is. Sorry about that. Import that. And then we're going to say student var student dataset is equal to pd.read CSV sep is equal to that. So we read this data and we do the usual things, right? We kind of like check the shape or something, and we can do the head, right? The usual inspections that we're doing. Let's look at the top 2 records or something, transpose them and all those things, the usual stuff, transpose.t. And then because we've imported these things and say, well, what we want to do is we want to see a slice, right? We want to see the, you know this, right? This is a dataset.columns, not clip, sorry, but .column. We want to draw a histogram of exam scores here and just see the distribution, right? So it's a final examination or something. We have this data here. And it's going to say, well, we would like to do a PLT dot histogram, right? And what we're going to do is we're going to plot a histogram of these scores here. I hope this works here. I don't know if the binning is going to be done on our behalf here. Oh, come on. PLT, sorry about that. I'm going to say PLT dot histogram, like that. Then I'm just going to copy this. You know, I've installed this thing in a very bizarre way here. As soon as there we go, right? And then I'm going to say PLT.show, something like that, right? And then what I have is a distribution of the scores. Yeah, it shows you, well, the distribution is obviously not non-normal and stuff, whatever that means here. And we see that a lot of students here are clustered somewhere around the 60s, although we have people that failed, quite a number of them that failed and stuff, right? It's a huge number that failed, right? You have like 30 plus 10 plus 10 plus somewhere around 2 or something. It's quite a lot, really. Okay, so this is what we're going to do. The workflow is simple, right? At the very basic, every time you're plotting, in fact, when you're creating your pipeline, what we're trying to say here is a pipeline that's tied to data mining. At the very least, is what the import statements that you have in your notebook is going to be import pandas as PD and also import matplotlib.pyplot as PLT. Okay. Anyways, so I mean, if you're wondering, well, but so what is this plotting all about, right? What you're doing when you're using Matplotlib is you're building the plot from scratch. And it's important that we understand this notion of building a plot from scratch, right? Because under normal circumstances, in an ideal case, right, when you're playing around with data, I don't know about you here, but I'm assuming you did this maybe in first year, actually. When you're working with data like this, the normal thing for you to do is you'd say, well, I want to, distribution of what? Exam scores. Okay. If it's exam scores, I'm going to open up Google what do you call this? Google Sheets, right? Come here and I want to say, I want to create a histogram, right? We insert a chart or something like that. What type of chart is it? Well, I want to create not a pie chart, but I want to create a histogram. Scroll down here, and where's the histogram here? I want to create the hell is it? No, it's a line plot here. It's a bit strange here that there's no. I think you need to do a little bit of binning and stuff, right, for you to create a distribution plot. This is there we go, a histogram, right? Okay, and everything happens by default, is it? The moment I do this, right? I think the chart should be somewhere to the right here. I hope. I don't know. I can't see it. You know, sometimes this thing, I don't know what is happening here. I don't know where the chart is here. But your chart will probably appear somewhere, right? I'm gonna do this again. Yeah, I think I need to create beans or something. But let me use another example. The way we create plots here is, let's say I want to do a plot of a bar plot, a horizontal bar plot, as it reflects or as it showcases the performance of the various cost miners. Well, I will first of all start by summarizing this information. So I'll create a pivot or something like that, right? It's a simple workflow. I'm trying to showcase a workflow here and how varied it is when you compare it with what you do when you're building your graphics, your best graphics using PyPlot. Okay. So I say, well, I want this to be my values, the final exam score. Okay. And then what else? And it's going to be average score is what I'm interested in, because I want to segment these based on, I'm going to do this here, based on the minor, the cost minor. And then I'm going to pull the minor here and put it as a row or something like that. And then you have something like this, is it? You've pivoted this data, you've summarized it, right? After you summarize this data, you can then easily plot, right? So I'll come here and I'll tell, Google Sheets to say, I want you to insert a chart for me. And the chart I want you to insert is not a histogram, but because I'm not interested in distributions, average scores, is it? So I want my personal favorite here. I want to draw a bar plot, a horizontal bar plot like this. And you're done with your visualization, right? Afterwards, when you do this, you can start doing your fancy things. If you remember your first year, when you were being taught how to use these tools, right? So, well, we're going to customize this plot and maybe make sure that the text, I don't want this to be in gray or something like that. So I'm going to come here and I'd say, well, I want this to be, in fact, I want it to be centered. I want it to be the color itself. I want it to be black or perhaps red or something like that. I don't know. I want it to be bold, right? Maybe in italics or something like that. What else do I want? Well, I want to make sure that these labels here should be in bold as well. So I select them and then I choose, I want this to be bold. What else? I want to change the descriptions of the axis labels, right? I want this to be minor program, not minor description. So I say minor program or something like that. What else? Well, I want the label for the x-axis here is flipped to y-axis, but still x-axis. I want this to be examination scores in percentages, so that whoever is reading this plot knows what I'm talking about. I want this to be in bold or something like that. You can do a whole range of things in terms of kind of customizing these, right? Whether you're using Google Sheets or you're using Excel or LibreOffice, Calc, right? Doesn't matter. The idea is it's an intuitive process. It's user-friendly. I want to argue here, quite efficient. If you know how to use these tools, you're usually quite efficient at doing this. It turns out, though, that when you're plotting using Matplotlib, you're going to have to assemble this plot piece by piece yourself. Okay? And just to mention here that what we're going to be doing when you're showcasing how you assemble the plot is, we're going to be making reference to things like, the figure, right? We're referring to the entire window or the page that is drawn. So when I did this here, and I said, sure, right? This is the figure, the entire thing. The axis here, the axis is the area where you do your actual plot. And then the title is the piece of text that comes at the top of the figure itself. Usually it's common practice for you to to provide a chart title or something, not exactly mandatory, especially if you insert this thing in a document, a long document like your reports, for instance. No need to add your title, is it? It's always nice, standard practice, but no need, because you'd have like a figure caption, right? Figure 1, blah 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 blah. So it's redundant for you to have a title or something, and then your x-axis label is just the label for the horizontal axis. So in this particular case, is test 1 score, and then the y-axis label here is the label for the vertical axis, right? This is like final examination score. It's always nice. It's expected that you add axes to your plots, depending on what sort of plot. I mean, if you're plotting a pie chart, right? If you're plotting a pie chart, you probably wouldn't want to observe. If you're plotting a pie chart, right? You come here and you say plot.pie, and you say 20%. Is it 20, 50, 60, 90, and then 100 or something? Do that, and then what I'm trying to say here is when you have a pie chart, right? Is there a difference, ladies and gentlemen? What's the difference between a plot and a chart, by the way? Plot, chart, graph. We don't know, Lighton. I don't. Okay, so like when you have a pie chart like this, right? I mean, you wouldn't want to have like x-axis and y-axis labels. Do you understand what I mean here? People would look at you strange, right? I'm trying to say that in some instances, you don't necessarily need your x-axis labels or y-axis labels here. In some instances, you will need a legend, right? So in this particular case, what you're seeing on the top right corner here, where we have STEM students and social science students, so that when somebody is reading this plot, they know that all these blue dots represent performance from individual students enrolled in STEM-centric minors or program minors. Legend, right? You know about legends here. Anyways, so it turns out the process you go through. I mean, in the past, I've kind of provided different. Maybe I should showcase this. I've provided a different heuristic for plotting, but when I started assembling slides for this course, I figured, this thing must be somewhat different here. Slides, and then I don't even know what lecture that is. I think it's lecture 2 or something. I hope. I think it is Python for data mining. In this particular course, what I was showcasing master's students here is that when you're plotting, we're following this heuristic where you say for you to plot a graph, what do? You import Matplotlib, you draw the plot, you specify the plot aesthetics, and then you render the plot. It's like generic. But for you guys, I mean, we've kind of simplified things a little here, right? But fundamentally, these are the series of steps that you do when you're plotting a plot in Matplotlib, right? You import the package, you draw the plot, and then because you're building it from scratch, you apply any aesthetics. Like, oh, we want to add a title, we want to add an x-axis label, y-axis label, we need a legend, and all those things, and then you render. You typically render by typing matplot.pyplot.show. This is one of the reasons why I was typing here. plt.show, I'm rendering the plot. You have got to explicitly render it. If you notice, if I just type py, it returns, right? It returns this object here of type tuple, right? So this is a tuple that comprises information about how I'm going to draw or render this plot. So I've got to explicitly say plt.show to render the plot itself, okay? Anyhow, so we're saying here, our first step in CSC 4792 here is, obviously I've got to prepare the data first, right? And we know how to prepare the data using Python pandas. You do a pd.read underbar, whatever, right? If need be, you filter data. Like, I don't want to plot things that have now values for this particular variable or attribute. I want to just plot students that failed, right? Okay, that's fine, or maybe you want to aggregate. So you're using Python pandas to prepare the data prior to visualizing the information itself. Typically, you'd even go so far as to group the information, is it? And then after you group the information, we pivot it using Python pandas, you can then create the plot. So we're going to create the plot by calling pyplot, is it? Remember, we are saying import. We're saying import matplot.pyplot here. Matplot.pyplot as PLT, right? When you import this, we create the plot by evoking the appropriate function that enables us to draw the plot we desire. PLT dot, a whole range of things here. You can draw a pie chart, right? A line plot, right? A whole range of things. What else can you see? What other stuff do you guys know here? Ooh, dot. Yeah. Anyway, there's a whole range of things here. A whole range of things. Anyway. Yeah, a whole range of things. I wanted to do another thing, but that's okay. We'll look at this here. At your own time, I do encourage you to, what you want to do here is PLT, just do a help here, right? And then you have the sense of the range of things that you can plot here with specific examples. Like, it's wonderful. Life is actually easy these days. You don't have to worry about this thing. Everything is there for you. It's so easy. Or you can use the dir built-in function, is it? You can draw a box plot, like I said. What else can we do here? PLT is what you use to specify aesthetics. You notice here PLT.legend, you specify the legend, vertical bar plot, a horizontal bar plot, a whole slew of visuals that you can use here, subplots and all those things. Wonderful stuff. Anyway, so we create the plot and then we customize it. In other words, you're applying aesthetics to the plot itself. And then you render the plot itself. Boom, done. PLT.show, right? So just to showcase some examples, right? As you will see them in the notebook, which is available on the Moodle. I don't think it's necessary for us to, before our class tomorrow, I don't think I have to walk you through the notebooks. This is what happens, right? I mean, I've provided you with a notebook. I'm explaining to you how these things work, so you can play back the notebook, I suppose. But so, when you're plotting something like a bar plot here, I don't want to call it a chart here, it's a bar plot. Let's say we wanted to compare quantities across, typically you'd use this to compare quantities across different categories, right? A bar plot, comparing, if you notice what I was showcasing here, we are comparing scores across these categories, program minors. We could change this here and say we want to compare, I'm going to come here. We want to compare not the program minors, but we want to compare differences as they appear when we look at those that are accommodated versus those that are not accommodated. So it's rows here. I'm going to replace these things with like this, right? And maybe just say don't show the things here. And you notice here that the difference is not really that much, right? In terms of accommodation status. We are comparing across categories, the categories of accommodation status. In as much as those who are not accommodated on average perform, or in as much as those that are accommodated perform better than those that are not accommodated on average, you can see the bar plot. Variation is not that huge. It's not that huge. And in fact, if you're sort of person who says, no, I'm not going to listen to Lighton here, I will use our own thing here. I'll use my own, I'll use Google Sheets or something. You can even add this sort of aesthetics, is it? Major grid and ticks and all those things, right? So that it's much more visually appealing to whoever is going to be looking at this graph here. So you use bar plots to compare quantities across different categories. Like for instance, in our example, let's say if we wanted to compare performance of students, right, by sponsorship or something. You notice here we've imported Python. We do an import pandas as PD and import matplotlib.pyplot as PLT. What we then do is we use Python pandas here we are summarizing, right? Because we cannot, if we want to compare across sponsors, observe, ladies and gentlemen, if we want to compare against sponsors, what we're saying is we're interested in columns, and then we're interested in this. Where's the sponsor here? We're interested in sponsor, like so. This is what we're interested in. But it's like, so we want to visualize how many are sponsored by government fully and all that stuff, right? Well, we have got to summarize this information somehow. And what I'm showcasing here is the value counts, right? Value counts, which does the summarization here, if you notice, dot value counts. And so all I'm doing here is I'm saying I'm going to create a variable called sponsors summary is equal to this. And then I can then use Matplotlib to plot a bar plot, is it? A bar plot of these things here that you're seeing against their corresponding values, right? This is why in here we are saying we're going to get the value. So plt dot bar, you know, I don't like bar, but I'll showcase. Well, I don't like bars, to be honest, because I don't drink also. But I mean the bar plots. I don't. I prefer. I much prefer. I much prefer, to be honest, myself. I much prefer. Horizontal bar plots. So observe. If I plot this, right, it's going to pop up like this. Sorry, it's overwriting what was what was already there. But you know what I needed to showcase is this. This, right? What I was saying is, for me, if you look at the things that I write about, usually you will find me using, instead of bar, you will find me using bar H, which is a horizontal bar plot, just because I think it's more aesthetically pleasing and it makes optimal use of the space that you have at your disposal, something like this. All right. So you know, and then you know, that's an example of the bar plot, right? A bar plot takes in at a bare minimum, it's the labels you're going to have. It's like these things here, the yes or no, comma, the values. The values are the actual quantities. So it's like I wanted to say, I want to plot genders, right? In CSC 57, an average scores for genders, males and females. I want to showcase the variation as it relates to these things here. See that the average for females is 74. How about students here? 66 or something like that. It's supposed to be PLT, not plot. PLT dot that, and then I can do a PLT dot show, and it's going to bring up this stuff here, males and females. So in other words, we're saying that I mean, you can look up this information by just doing a PLT dot bar, and then you do a help, is it, to figure out exactly. There will even be a series of examples, right? Figure out the key-weighted parameters that you need to feed this thing here. You notice the aesthetics, you can add the width and the height and stuff, right? If you think these are too fat for you, the width is just too much, is it? It's like you're saying, well, this thing here, when I render this plot here, this is too much here. These are too much here. You can reduce the width. This is what they're telling you here. Okay, that's okay also. So that's a bar plot, right? And then you have your line plot where you know you feed it x-axis values and y-axis values, right? So for instance, if you wanted to plot let's say values against a certain year or something like that, right, on your xy plane, your x-axis values would be on the left and your y-axis values would be on your y. It's like we want to see average scores across the years for data mining. Okay, well, we're going to say I don't know what this is here, but we're going to say PLT dot PLT dot plot, right? Plot And then we're saying that x-axis value. So maybe in the x-axis, we want to showcase that in 2020, COVID here, 2021, 2022, 2023, 2024. But we don't know about now. Comma, on the y-axis, the average scores. In 2020, because of COVID, the average performance in the course was horrible. So we had an average score of 48%. In 2021, it got much better here, but it was just 52. And then after the pandemic, it was okay, 66, maybe 79% or something. Plot like that, right? 1, 2, 4, 2, 4, 5. I have 5. The shape is different. And then it's like 80 or something like that. And then I just pot.show, yeah? And then I'll have this graph, a line plot that kind of, it shows you to say, oh, and if you give this to somebody, right? We see here that, the average score was horrible during the pandemic, but after the pandemic, things normalized or something like that, right? That's your line plot. You typically use it to show trends, right? A progression over a continuous sequence. And usually you use these things when you're looking at data from a temporal perspective, right? There's some time element associated with the data that you're dealing with, right? Years, plot against years or something like that. Anyway, so it's trivial enough. And then your histogram just showcases a distribution, right? Over, you're visualizing numeric scores, which vary over a given range. That range could be percentage scores, because scores range from 0 to 100%, 0% to 100. It's continuous. Somebody can get 0.112, right? Or 2.5 or something, or 2.53%. If you understand. So you do this, you can specify the bins and stuff. I don't know what that is. I'll ask you to maybe mute the microphone, please. Whoever that is, that stuff here. And then you have like your scatter plots when you're trying to determine the relationship amongst two numeric variables. Well, we want to see the relationship between when students, the relationship between what? The student scores is a paper we tried to put together. We may submit it somewhere here. And how often they access the Moodle, right? These are all continuous variables you're comparing against. And we're creating a cluster here, by the way. This is pretty intuitive here. So what we want to do here is we have shared the Google Colab. I know you have access to this because I've given you access to Google Colab. It's on the Moodle also. Play it back. There's a series of examples that speak to the things we've discussed. And then I want to pause here and ask, find out if they have questions, but just to remind you that we have class tomorrow at 18. We are making up here. We did not have, we want to make up for lost time, 18 hours. I've already scheduled this session, but we use the same link. So just tune in. In fact, you also have the calendar, right? You bookmark the calendar. Are there any questions about Matplotlib? No answer. Okay, thank you very much, ladies and gentlemen. I'll see you tomorrow at 18 hours. Bye for now.
There's 2 or 3 that 18 hours.